Hey everyone, so we're looking at Unit 3, Lesson 3, Applications of Rational Functions. So everyone's favorite, word problems. We're just going to look at how we can model these situations using rational functions. But first, just a quick review on how to solve literal equations. So this is something that we have kind of done before. You have multiple variables and you're solving for a specified variable. So we're just combining kind of what we did in Unit 1 with what we just did last lesson. So for like this one, for example, we're just going to go ahead and cross multiply. So I get negative 7 times x plus 5 is equal to, and then I'm going to multiply this way. And I used the negative already, so I'm going to say 3 times y minus 2. It really wouldn't have mattered which one I put that on. But I took it with the first one. So distribute through, negative 7x minus 35 equals 3y minus 6. Now, I'm trying to solve this one for y, so I want to get this one by itself. So from there, I'm just going to add the 6 over. And so I get negative 7x minus 29 is equal to 3y, and then divide by 3. Now those don't divide evenly by 3, so I'm just going to leave it like that. So y equals negative 7x minus 29 over 3, and that will be my final answer. You could also write this as y equals negative 7 over 3x minus 29 over 3, and hopefully you recognize that as slope-intercept form for a linear function. All right, so no matter what we're solving for, we can use that same process. So you're just trying to isolate a variable. Now, remember from Unit 1, and you can go back and look at those problems. When we have two of that same variable and it's located in different terms that are not alike, we're going to end up factoring at some point. All right, but the first thing I want to do is get rid of the nr plus r off the bottom. So I'm going to multiply that to both sides of this equation. So I end up with I times nr plus r is equal to, oops, lowercase n e. So I'm just going to distribute through here. So I have I in R plus IR equals NE. And then again, going back to that problem that we've done before in our Unit 1, we're going to get all of those variables that we want to solve for on the same side. So I'm going to subtract I and R. You could also subtract IR and NE. It's really up to you. So I have IR is equal to NE minus INR. And now that that is all on one side, I can pull out an N. So it doesn't go anywhere. Remember, it just comes to the outside. You're undistributing it. So we end up with something like this. Now we've gone from having two n's to having a single n. We've factored it out or undistributed it. So your very last step is to divide by EIR, E minus IR, excuse me, and that will be your final answer. Now, if you subtracted the other way earlier on, then all of your signs will be flipped. Please note that these do not cancel. We can't not cancel terms, only factors. And so you might have negative RI. Where did my capital R go? Oh, this is capital R. Sorry. The top one might be negative and these two signs might be flipped. It depends on what you did at this step right here. Okay. All right, kind of following that same logic, use your inverse operations and solve this one for v squared. So not v by itself, you just want v squared equals what? Okay, so you can multiply by r over m and get rid of it all in one step if you'd like. I just broke it down into two. Multiply by r off the bottom so that those cancel, and then divide by m so that those cancel. All right, so the second part of this problem says if capital F is equal to 10, M is 8, V is 6, find R. And so we have 6 squared is equal to 10, R divided by 8. All right, so we're going to follow similar steps here to get the r by itself that we did to get the v squared by itself. So we have 36, and we're going to multiply then that by 8. So times 8 times 8. And that's equal to 10r. Go ahead and solve that the rest of the way out. And hopefully you got 28.8. All right, now getting into these word problems, and these will hopefully kind of look familiar because we've done rate, time, distance problems before. Okay, the setup for this will actually be a little bit different because we're introducing in rational functions. So Michelle drove her empty rig 300 miles. And I'm just going to kind of highlight as I go here. So here's a distance, 300 miles. Just align it to pick up a load of cattle. When her rig was fully loaded, so we have full, her average speed was 10 miles per hour less than when her rig was empty. If her return trip took 1 hour longer, and that's time, so we'll switch colors again. Return trip 1 hour longer, so this is again full. Then what was her average speed empty? Okay, so we know that her empty rate, let's call it x, that her full rate would then be 10 less than that. Okay, you could also do x as full and then x plus 10 as empty. Either of those is fine, but we need to show that 10 miles less than. All right. We know that her total distance was 300 and that she went the same distance both ways. Okay. Now, you could introduce a second variable and solve this as a system. Since we haven't done systems yet in this class, we're gonna... Okay, so since rate times time equals distance, we can also say that distance divided by rate is equal to time. And so we can write these expressions here. So we have 300 divided by x and 300 divided by x minus 10. Keep in mind we're letting x equal the speed or the rate when empty. That's where the x is. Okay. So we also know that the time when empty is equal to the time when full minus 1 hour. Okay. Well, now we have expressions for time. We're just going to plug those in. So time when empty is 300 divided by x. The time when full is 300 divided by x minus 10 minus 1. All right. So now that this problem is set up, it is a rational equation. So I want you to go ahead and calculate the LCD and try to solve this one out for x. Okay, so your LCD should be x and x minus 10. We don't need to worry about that 1. We're just looking at the denominators. So we multiply through by everything. And cancel out from top to bottom. And then we end up with this. So if we distribute, we get 300x minus 3,000 equals 300x minus x squared plus 10x. All right, so we see here that we have a quadratic. We also, hopefully you see that you have a 300x on both sides, so you can cancel that out. I'm actually going to move everything to the left so that my x squared becomes positive x squared. So anytime I have a negative x squared, I try to get rid of that negative so that it's easier to solve. So I'm going to get x squared minus 10x minus 3,000 is equal to 0. Okay, and then I'm going to factor that out, and just to save some time, hopefully you tried this on your own, I have x minus 60 and x plus 50 equals 0. So I get x equals 60 and x equals 50. Well, excuse me, negative 50. Keep in mind I am talking about a speed. So even though these are usually both of your speeds, we're going to ignore the negative answer because it is speed, and speed can't be negative. So the average speed when empty is 60 miles per hour. Well, that also means that if I asked you for the speed when full, you would just take away 10 and get that 50. So notice that we had that 50, it just happened to be negative. That's usually your other variable. Okay? So the average speed when empty is 60 miles per hour. If I asked you the time, you would just substitute that back in for like the x here or the x here and divide, and you would have the time it took as well. So you can answer any of those questions by finding x first. All right. Let's look at this work rate problem. So this one is kind of new in terms of like RTDs we've at least seen, but it's going to be set up similarly to those. So what you need to know about a work rate problem is that the work is equal to the rate or the speed that you're doing it times the amount of time. All right, so again, real similar to an RTD problem. Bill can do the inventory by himself in 8 hours. Hilda can do the same job by herself in 6 hours. Assuming they do not interfere with each other, how long will it take them to do the inventory working together? Okay, so let's look here. Bill, his rate is 1 job in 8 hours. And we don't know his time because we don't know the time it takes them to do it. While Hilda is 1 job in 6 hours, and same thing. It's the same amount of time. All right, they're splitting the job, but we don't know how long that is. So our equation would be 1/8 x plus 1/6 x, right, is equal to 1 job done. All right, this would be 100% of work. So 100% as a decimal. Okay. All right, so this is your rational equation. So we're going to multiply through by the LCD. The LCD of 6 and 8 is the first number that they both go into, a common multiple, which in this case would be 24. So I'm going to multiply everything by 24, which cancels out your fractions. So 24 divided by 8 is 3x. 24 divided by 6 is 4x. n equals to 24. Make sure you distribute that to both sides. All right, so 7x equals 24. And then we just divide that 7 over. And x equals 24 over 7, which is equal to 3 3/4. I don't know why I changed it down here. 3 3/7, excuse me. Which is equal to 3 hours plus 3/7 of an hour. And we're going to multiply that by 60 to convert that to minutes. So it is about, if you do that in your calculator, 3 hours and 27 minutes. Okay. Now, there is a shortcut to this that we can run through real quick. And so this is where the formula comes from. But this is your shortcut. You can just do time 1 times time 2 divided by time 1 times time 2. Okay, and that, it gets you to the same place. So let me show you how that works. So time 1 is 8. Time 2 is 6. So we're going to multiply on the top and add on the bottom. And so we get 48 over 14, which reduces to 24 over 7, which we saw turns into that. So you can see that works the same way. All right, so moving into this next one. Linda can mow a certain lawn with her riding lawnmower in 4 hours. When Linda uses a riding mower and Rebecca operates the push mower, it takes them 3 hours to mow the lawn. This time we have the total time. How long would it take Rebecca to mow the lawn by herself? So remember that work is equal to rate times time. This time we have the total time. We know that it's going to be 3 hours total. So Linda is doing one job in 4 hours when she's by herself. All right, so that's her rate. She's going to work for 3 hours this time. This is their time together. So this is rate, this is time. Oops, forgot her rate. Rebecca does one job, but we don't know how long it takes her by herself. It never said. So if she was just doing the push mower, it'd probably take her an extremely long time, but that is what we're actually going to find out. She is still only working 3 hours this day. Right? So multiply those together, and 3/4 plus 3 over x is equal to 1 lawn mowed. All right, so your LCD for this problem would be 4x. So we're going to multiply everything by 4x. Those 4's cancel. That gives us 3x. These x's cancel. That gives us 12. And that is still 4x. Subtract the 3x over, and 12 is equal to x, which tells us that it takes Rebecca 12 hours by herself. All right, that seems reasonable since it's taking 4 hours on a rider and she is going to push it the whole time. This way also has a shortcut. It's similar, only this time, think about what we would do with those times on the bottom, since we have total time. So we're going to take time 1 times time 2 divided by time 1 time 2. What do you think goes here? All right, we're going to subtract because, again, we have the total time given to us. So we have a larger time. We have the total time, excuse me, than both parts. So we don't want to add those together. So look at your percent mixture problems and similar. If we had the total, we were subtracting instead of adding. So time 1 was 4 hours. Time 2 is 3. The larger time is 4, so I'm going to put that first and subtract 3. 4 times 3 is 12. 4 minus 3 is 1. So that gives us that 12 hours that we had. So you're welcome to do it that way. Just make sure you know when to add and when to subtract. All right, last one. Patrick bought 50 pounds of hamburger and steak. Steak costs twice as much per pound as hamburger. If he bought $30 worth of hamburger and $90 worth of steak, then how many pounds of each did he buy? So I'm just going to get this set up real quick for you. Just think about the formula. We have the price times the weight will equal your total cost. So you could also say that your price is equal to the total cost divided by the weight. I kind of set these up like my RTD problems. So we have burger and steak. And we have the price per pound the weight and the total price. Okay, so let's see here. Patrick bought 50 pounds of hamburger and steak. So we know the total weight is 50. All right, one of these needs to be X, doesn't matter which one. The other one would then be 50 minus X. So again, reference your mixture problem. If you have a total, we assign a variable to one of them, and the other part will be your total minus that part. All right. If he bought $30 worth of hamburgers, so $30 worth of hamburger is a total price for burger is 30. And $90 worth of steak, again, total price, so 90. And then remember that your price per pound will be your total price divided by your weight. So I can just take 30 divided by the weight of burger and 90 divided by the weight of steak. And that will be my price per pound. Then how many pounds of each did he buy? All right, so we let X equal the weight of the burger. So keep that in mind when you solve it so you know what you found. And be aware of the question. How many pounds of each we want to know. Let's see. There should be, right here, steak costs twice as much per pound as hamburger. So that is information that we need. Steak cost is equal to 2 times hamburger. Cost. And that's cost per pound. All right, well, I know the pound. So I know that the steak, and I'm just going to plug this in, is equal to 2 times what my hamburger is. All right, and I want you to go ahead and solve that. Okay, so hopefully you were able to solve that out. I just used cross multiplication, and then I distributed my 60. I added that 60x over and divided. So I got x equals 20. So what does that mean in terms of your solution? Okay, well, based off what our 20 means, weight of the burger. He got 20 pounds of hamburger, so he got 50 minus 20, which is 30 pounds of steak. All right, let me know if you have any questions. That is all for now. Have a good night. Good night.